help me welcome Kinzen up to the stage.
Thank you very much. Yeah, someone's got to win that whiskey. I figure this will go better for you if you just all share the whiskey and drink it now. Okay, so my name is Kenzon, and just want to say this is a great city. Ashley and Brandon have been showing us around. Brandon tried to take us on a brewery tour, but didn't quite work out. I'd just like to start with this slide because ultimately at the center of what we do, it's really handmade. And that's something that's really important to me. So yeah, I want to thank Dale, especially. She put this together for us. Really appreciate all the help she did. And Evan, Michael, and John and Brandon, especially Ashley and Brandon for showing us around all weekend. I've known Ashley since 2005. She was pregnant with Esther when she gave her thesis presentation. So, and then also my business partner and father, Glenn, he's right here. You can wave, put your hand up. And my fiance Ola has been a part of Studio 1000 even since we had a name for it. So she's also here. Supporting. Thank you. Our main goal at Studio 1000 is to make light-based, site-specific work. And we do that mostly, pretty much completely with architects. There's a lot that goes into it, and we try and help architects build kind of precious spaces. Studio 1000 is 2 people. It's me and my father, Glenn. I went to Pratt for industrial design, and Glenn has been running small businesses for many years. He has really built Studio 1000 to a level that I never could imagine through a lot of back office proving to other people that we are legit. You know, you can't walk into the office at Turner Construction and just kind of song and dance your way through it. So quickly, there's a variety of things that I use as inspiration. It's a lot of nature and it's a lot of kind of technology-based things. I grew up in an arts family, so I had that going, and you know, I've just kind of ended up reading a lot of sci-fi and stuff like that. Let's see, can't get through PowerPoint without using dumb clip art, but yeah, this is basically where we exist. And people say to you when you start a small business that if you're combining 2 industries, you're not out there by yourself. You're competing with both of these industries. So you kind of make it twice as hard for yourself. But I think that we provide a good product and we have fun doing it most of the time. We also do our work in a way that we learned, sometimes the hard way, that this is not how things are done in the design and construction business. But we basically run our projects from start to finish. So if a lighting designer or an architect or even a client reaches out to us, we sit there and we talk to them and we come up with something that fits in the space and in the budget and what they dream of. But we go all the way through. We talk to the GC and then we're on site with the electricians as they kind of install these non-standard fixtures. So that has been confusing to some people, but when they have tried to go around this process without us, they generally call us and ask us to show up. Working in a number of different areas. Let's see, let's call these process ideas. We're trying to build things in LED that are non-standard, that are not the same as what you see or expect. Also, for me, as an arts based person, as an artist, I'm really thinking about how do we make an experience with this object, just the light itself, that's what I'm interested in, and I want you to just have this light experience. Since I went to industrial design school, I think about just mass production, and can we make things with repeated elements? So we design one thing and then we deploy it across and in interesting ways. And this funny little thing, futurism based in handcraft. I grew up watching my grandfather and my uncle, basically they were pounding out sculptures out of sheets of bronze. And we were all running around in the driveway getting bronze splinters in our feet, which are not fun. So I really tried to maintain this handcraft even in the work. And as kind of technologically forward as it looks, like we rely on a series of artisans essentially to make this stuff by hand. And yeah, this kind of sums it up. I've been in video production, I've worked in fabrication studios, I've done all sorts of arts production, and honestly, everyone goes through the same processes of figuring out what we're doing, figuring out what we're making it, all these things, but they all go through it in kind of different ways. And the goal for me is to try and find the best way, even if it's not in the industry that I'm working in, to make the best process possible. All of our work is made in a barn in Maine, like quite literally, this is the side of the barn. It's like any barn you might see in the country, except it's in Maine, so there's like 3 non-working boats in there. You know, I don't think that Volvo works. I don't know if that tractor works, but yeah, like when I go up there to work with them, this is where I sit. Like his son is sitting there. There's like a couple of outboard motors that are gonna be fixed. So it's a real cottage industry, honestly. I want to take a little bit of time to talk a little bit about human interaction with light and what we do. And this is obviously the first page of the Bible right here. I think anyone who works in lighting in a real deep level kind of has to be spiritual in some sort of way, because at the end of the day, the core of lighting, we don't really have all the answers for light. We don't know. It's been around for a long time, from a science perspective, light became a thing only 300,000 years after the Big Bang, and we don't really even know what the Big Bang was. And like matter doesn't even show up for another 60 million years. So here we are, we get to us. 2 main sensors that we have for lighting are skin and our eyes. We use the same protein in both, so you could transplant skin into your eyes. That's not true. It's actually, it is kind of true. They have tried this in mice and it has started working. But in your skin, basically, it's basically telling and deciding how tan to get based on how much sun you're getting. And then the eyes, obviously, these same proteins are lining the back of your eyeball in rods and cones. So your brain deals with light, the perception of light, in 2 ways. First, it goes to this thing called the thalamus, which is essentially the top of your brain stem. This is what you could also call like the lizard brain. And this is making decisions before you can even figure out what's going on, which is essentially because those milliseconds that it makes decisions, if you jump away, that's really the difference between being someone else's food or catching your own food. So it's moving real fast. And then afterwards, if it decides that everything's still safe, it moves all these things back to the back of the brain, which is called the visual cortex. And that's where the brain is actually figuring out and comprehending what we're looking at. So across the top, the brain is looking for contrasts and edges all the time. So that's one of the main reasons that it figures out what's going on. It's looking for colors, trying to figure out whether you should eat something or not. And it's also looking for symmetry. And I know that, as architects, we all, we're all very familiar with symmetry, but from an evolutionary standpoint, what you realize is that actually in the natural world, nearly all the landscape is non-symmetric and nearly all animals are symmetric. So the reason we're so clued into this is because the only thing that is going to eat us is symmetric. So when you're swimming around or laying in the grass, you're looking for something that looks the same on both sides. I think humans, kind of as we've evolved and kind of had a better sense of lighting and this type of thing, I think we're always looking for something rather surprising, iterating on the same thing. We could look at sunset hundreds of times. It's always different, and that kind of surprise of the same thing is always really pleasurable. I think that we maintain and create memories through these multi-sensory experiences, like fireworks. It's a light show, but then also I think we all expect and kind of enjoy the bang as well. And one of the things that I'm trying to do is to kind of isolate the visual memories out of these experiences to kind of distill those and then repurpose them into thoughtful projects and installations. And then light, since we figured out fire and stuff like this, light has always been a part of kind of a comfort and coziness that we have desired. And I think for us, especially installing a lot of central pieces, it's something that we've learned is never really talked about in the design process. I think it's kind of hard to tell your client that you want to make something really cozy. Just doesn't really go over in the meeting. But then when people actually end up being there, it's been a serious percentage of the feedback that people like, we like it because it's cozy. Okay, great. I went to grad school again with Ashley and kind of came out with this question, like, am I a designer with artistic tendencies or an artist with industrial design tendencies? And after many years, I'm going to go with number 2. Because when I did my thesis, one of my professors said, oh, you should make this into a table lamp, a floor lamp, a pendant light. And I was like, I don't want to do that. When I was going to school, and even today, this is what LED desk lamps, at least on the cheaper end, look like. Even on the nicer end, they're almost always flat. And the reason is because LEDs are an outgrowth of the electronics industry. It's a diode. It's right next to a resistor, a capacitor. And this is how you make electronics, on a flat circuit board. It's the most efficient way, and obviously these proliferate through our life. And I just wanted to make things that were non-flat. I don't think that flat is really kind of a enjoyable specific thing for humans. And you can bring more interest into the space doing things like this. This is the other piece that I made. Oh, I just want to say that Ola helped me wire this. And there was a couple of really long nights. This is the other piece that I made. I was really into Japanese basketry for a while, and I can honestly say that I have a thesis and a design degree in basketry, which some people scoff at, but this was not very easy to make. So, okay, projects. And we're gonna run through 6 of them quickly. Chicago. This is the first project we did. This postcard of that image that you saw was it's actually back there. You can have one. Own this piece of history. This was sitting in a coffee shop and someone from Todd Williams and Billy Tien picked it up and said, this is what we're looking for. And they called me while I was unemployed and sitting in a beer garden. And I was like, yeah, cool. Well, I'll take the call. Yeah, I can go to this meeting. Sure. And then I kind of didn't even remember who they were, but I wrote their email down and I emailed them, and Todd Williams and Richard Renfro had sold this idea to the University of Chicago while they're building this huge arts building to soften this edge between this very beautiful, I think her name is Suzanne Tick fabric, it's acoustic fabric, and then this very nice cherry paneling. And they needed something to soften that edge. They wanted to make this in fiber optic, and the acoustic people, consultants for this, were like, hard no, no fans in an auditorium. And they were kind of stuck. So when Felix, the project architect, picked up this postcard, he was like, we got to find this guy. They still did hand drawings. Felix sent me this very nice drawing on the left. I butchered it in Illustrator on the right. I said, well, we could make these different heights. You know, we have a variety of ideas that we could do. They also said this thing has to fit within a 4-inch channel, which I was like, that's fine. That doesn't matter. Here's the prototype. This was made so that they could, it has 2 circuits, so it's either 1-inch or 2-inch spacing, and then you could kind of pull these out and rearrange them. I think a tactile prototype is always good for a client, something that they can play with and feel involved in the design process, because it builds their own ownership into the design process and product. This is the final one we made. They asked for it to be black, powder coated it. It's got a barrel plug at the bottom, so essentially installing these is like faster than a light bulb. You just, after you install the channel, you just plug them in. Here is the close-up view. So they installed mirrors in the back, and then this is a really nice piece of 2-way mirror. It's actually, the material's laminated between 2 pieces of glass. So it's like super high end. Apparently it took 7 months to get a sample. I don't know. 75 feet on both sides. It ties into the theatrical dimming system, which was its own set of challenges. But yeah, you can control this from the main theatrical lighting board, and it goes up and down, and it dims down to about 10%, 7%. We were kind of too young and dumb to figure out how much work this was going to be, and that's why we ended up doing it. But this is UL listed. It passed sound test. Yeah, a whole bunch of people had to prove this. One of the reasons that we're good at what we do, and one of the reasons that we are successful, is because my team up in Maine, they manufacture circuit boards. That's, besides me, one of their principles was designing like circuit boards for supercomputers. So when I showed up and said, can you put this LED on a circuit board? He was like, that's really easy. And I was like, okay, well, I'm going to ask for like 15 different types. I didn't tell him that immediately, but yeah, so the next one that we did was in New York for the Museum of the State of New York. This is the one that's probably the most famous. We designed this with Chris Cooper. He was at Cooper Joseph Studio at the time. He's since gone back to SOM, and now he's the creative director there, which is kind of New York luck. They had this stairway, and this is the rendering that they had sent. They had this stairway that was not really being used. This chandelier was original to the building. It's about 60 inches across in diameter, and it weighs like 1,300 pounds. It's cast bronze, and it was running at like 1,300 watts. It was like a lot of power for not a lot of light, and it just was not filling the space. It was not filling the space with light. It was not filling the space physically. And the architects helped the museum because the elevators are being overloaded with visitors, and no one could get back to the offices, which were above the exhibitions. So they wanted to activate this in some way. So someone in that office had come over from Todd Williams and Billy Tien, and they said, oh, well, you should call Kenzan because he did this thing in Chicago for us, and he might be able to help you. So they explained the idea, and we came up with this concept with these triangles, which you can see back there on your way out. These ones are made on a desktop CNC router. You can literally buy circuit board material and cut it out yourself, and then solder these together by hand. And we made a sample that's basically the same one that you see back there, but only in white light, not the colored ones. And we took it up there and we set it up. The executive director kind of walked out. We set it up in front of the space. The executive director kind of walked out and she goes, I love this. And then she went back to her office and we all kind of stared at ourselves like, what now? And the architect was like, said, that's kind of the fastest approval that we've ever had. So from there, we'd go to this. This is what makes this kind of complicated. This is about 400 LEDs on a single motherboard. And the reason that we make them like this is because you need to test these before they are put into fabrication process. These are wired so that you can wire up the whole board at once. Any LED that's going to fail is almost always going to fail in the first couple hours, maybe the first couple of days. So you blast them, you turn them on for about a week. Any of them fail, usually maybe less than 10 out of 5,000. And those are obviously removed and set aside. And then these are broken out by hand and soldered by hand. Literally 5,243 locations, 3 solder points each, in an MDF jig, and they were still able to get an average deviation of 7 thousandths of an inch, which I don't really understand how you're able to do that because I only think at about 1/4 inches, but it's amazing. There's about 10 different kinds. Obviously, if you remember the piece of the disc, so there was 10 different cable lengths. And after they're soldered together, we also left them kind of on at about 50%, just kind of in the studio. I think it's just also to remind people of how far we've gotten in the work. This is the back. You were asking about this. This is kind of like a duck, right? Underwater, swim as fast as possible. On top of the water, look as calm as possible. These are power supplies. They're made by Meanwell. You can buy these for about 70 bucks. This is something we make. This is the distribution box. And so from here, one wire goes to every position. So back of house on one of our lights, always a bird's nest. It always looks like this. There's a moment for us because we build things that are supposed to go into rather large spaces that we can never really install the whole thing at once in our space. We don't have a barn that's that big. You know, there was one, we'll see a piece that's like 69 feet tall. There's just no place to put that. We test each one individually, obviously, before we send it out. But there's this moment when you hang the first one, you're like, oh, this is going to be a really cool thing. And I think that that really helps kind of build momentum. And especially when the client shows up on this day, they're like, oh, wow, this is really going to be a cool thing. Here's the team. Matt on the left, he is the circuit board genius. His partner, John, is a mechanical engineering guy. The reason I've worked with these people for over 10 years, the first day I walked in there, they showed me the CNC router that they had built from scratch. So once they told me that, I was like, okay, you guys are the ones. And then this guy, Tom, he was literally the one who soldered every one of these pieces together. When someone says, who made this? Like, Tom. Beauty shot. And then you saw this piece earlier, but one thing that I will point out is that this building, the seam in the tile and this window and this thing is all on axis. And our installer who put this steel frame in the ceiling got it so that we are also on axis. And it is a joy to look at when you're standing there in person. We got that won a couple of awards, and someone from Gensler in DC called and said, we're working in this project in Nashville. And I apologize, we haven't gotten professional photos of this, but here's a couple that we took. This is the Life and Casualty building, Brandon's favorite building growing up. And he told me once that's why he's an architect. Every one of these pieces has its own kind of personality to them. And this one, especially because of this set of windows, it's like extra sparkly. All these windows at night, if you go in there, just reflect all of these lights together. We were dealing with the skylight and the ceiling also. That was new for us. This is the front if you've never been to Nashville, which seems confusing for this crowd. 4th and Church, right downtown, right? This is it in daytime. And this is now what it looks like at nighttime. One of the interesting things was that we put all the electronics on the ceiling, on the roof, which we all kind of scratched our heads at, but DC power loses voltage over distance. When Tesla said that he wanted to electrify New York, part of that plan was a coal power plant every 2 blocks, which doesn't seem like a good idea. But yeah, so the closest place to put this stuff was on the roof. And you know, it's hot, as we know, in the summer, but actually one thing that ended up happening is that there's AC pumping up through this borehole all the time. So actually inside the larger protective can, it's like 60 degrees in there all the time. Here's Philip from ABEC Electric. So we sent them this box. This is part of our scope of work. And what we always do is we buy a box that has this extra steel plate in it. So when you get the box, you could take all the electronics off, set them to the side, and then you can mount this box however you want. You know, the electricians, you do whatever you need to do. Then we can sweep it out, get all these metal shavings, all that stuff out of the way, and then do a clean install of the electronics, which are obviously allergic to metal shavings. So power comes in, power supplies, and then we had designed a new power distribution system. And we've designed about 5 of these now. We're up to about version 5, and they're getting easier and easier to install. So ground floor, and now there is a restaurant in the building, so you can actually sit and have a drink from this view. And this is what I mean by mechanically minimal. The goal is to make a light that all of the wires fade away and we have an experience just with the light. So when you stand there, especially at this time of day, all the wires just kind of fade into the background. I mean, you know, listen, if you want to like stare at the wire and look at it, be my guest. But if you're just sitting there having a drink, enjoying it, it goes from here and then it goes up like, I think it's 35 total feet. So it goes up another 25 feet from here. Later, we got asked to do this in RGBW in San Francisco. Here is the giant pile of people who worked on this, starting with the Golden State Warriors. Manica Design, Kansas City, they did the initial exterior and the arena design. And there's 2 major LED art projects in view in this. Leo Villarreal has the north side of this bridge. I don't know if you've seen it, but it's a huge algorithmic, it's very beautiful. And Jim Campbell has the top of this Salesforce tower. It's kind of showing scenes from around San Francisco. And I'm very happy to be included in this group. I'll just give you the money shot first. This is the night that we finished after 30 straight days of work. So sorry if my hands are a little shaky. But this is essentially a 69-foot tall three-dimensional video screen. It's 15 by 20 feet footprint. The bottom, it bottoms out about 15 feet above the floor. And we built a whole UI system for the clients. So whether they want to play, you know, Warriors versus Bucks, or, you know, the Grizzlies come to town or whatever, they can reprogram it for that. And then of course, newer stadiums, basketball is only, let's say, a third of their programming for the year. So if Lady Gaga shows up or anyone, they can kind of program this to do that. This potato quality JPEG is what we got in the email. This is what they sent this to us and said, can you do this? And we stupidly said yes. This had been value engineered out of in the first round. And about 24 months before the stadium was supposed to open, the client pointed to this rendering and said, and we're excited about this. And the client rep and the GC said, oh crap, we got to find someone to do this. They gave us 9 months to do this. We would have preferred, what would you say, Glenn, like 24 months? So here's the hole in the ceiling. It's a little bit of a weird shape. These two long edges are both radius, not the same radius, to the center of those circles. I think the radius is somewhere in the 350-foot range. The two short sides, not parallel, and the ceiling slopes down from right to left. It was kind of a crazy thing, but I will say that Rhino has some very amazing tools that you can do this automatically in. We chose to put panels above this space and not deal with the sloping ceiling at all. I like to take pictures of weird things that I see around construction sites because people get really upset about things. I don't know who's blocking the snack aisle. We installed 16 different panels, and the goal and the challenge was to get these aligned in the space with our electricians. And I have to say that Cupertino Electric, if you're doing a project in the Bay Area, these guys know what they're doing, and I will happily give you their contact information, especially their service department. If you have something non-standard for an electrician team to put together, call them and tell them to put the service department on it, because they're used to showing up to all sorts of weird calls and just figuring out how to make it work. The template panels were there. Sorry, let's go back 1 second. This white piece of Unistrut was attached to their Unistrut. So essentially what we did with these template panels is we put them up and we arranged them all. And I don't mean to take that lightly because it took us 4 days to do this correctly. But with these unfinished panels, we took that whole kind of delicateness off of the table. Like we were throwing these on the ground, they just sat on the ground. Something was in the wrong spot. You could use a hammer. You know, obviously you could reach through it. That really helped. And so when the final panels showed up with all of our mechanical and, you know, mounting stuff, mechanical, electrical, you know, and then obviously this really nice gold paint job that someone had specified, we could put these up. We could, you know, had all the shrink wrap and stuff on there, install it, and then take it off and not touch it. And they looked perfect. 15 out of 16 installed. We needed one way to get up inside there. Each of these Ethernet cords, it's not actually only Ethernet. You have to send power and data, so a plus and a minus for power and data, 4 connectors to each one of these locations. This is a prepackaged way that everyone understands how to install this. So we just bought these very nice high gauge Ethernet cables, and they had testers, so you know you can just run testers, and they're very easy to install. So one of the things we're trying to do on these crazy non-standard things is try and make it as easy as possible for the installation team to try and build things in a language that they speak. 75 feet down, here's what it looks like from the floor level. Remember that number when you see that this guy was out there for 20 days on a lift, cantilevered 25 feet from the mezzanine, installing these one at a time. There's Matt again, Glenn. This was basically our life for 30 days. And what we would do is validate and test, make sure every strand worked. And then the cam would come in from the lift. We went to Home Depot, we bought a bunch of shower hooks. And so those were all hanging off the basket, and we would load him up, and then he would go out there and install them. Digital side, we found these guys in Brooklyn called Volvox, and they are really beyond comprehension. When I went there the first time, they had just bought a 2-ton KUKA robot arm off eBay that they had installed LED panels to. And the robot was moving the panels around, and it looked like water was sloshing around in the box. And I was like, I don't even know how you do that. But they basically took our CAD model and figured out how to apply color to it. So they built this, and this is an early visualization. This is the UI. So the client comes in here either over the internet or USB stick, and you can schedule this. So next Thursday, the Warriors play this team. We can get it to do this. And on the right, obviously, you see the visualization of what's actually happening. So this sits in an IT room. So it looks like this. So on the right, there's this nice generative, and then on the left, this is kind of a test pattern. This runs at 60 frames per second, so it's better than television. And I like to describe it, I tell people it's basically like graphics from the 80s, but in 3D. And this is the money shot. It's, we're really proud of it. It took a lot of work. We've done other types of control systems. This is congregation Bet Simchat Torah. They're the first LGBT synagogue congregation in the world. And they had recently found and built out this space. This is an important part of any synagogue. This is the memorial wall. The week of your passing, your light lights up and people can come visit. It's kind of like going to the cemetery to visit with those who have passed on. This is what they were working with before. Essentially, someone would go around every week and hit these little buttons, which are just kind of light up buttons. You push it, it turns on. You push it, it turns off. We moved them to a web-based app. We install the server into their rack, and it pays attention to both the Gregorian calendar that nearly everyone uses, and also the Jewish calendar, which is now in the year 5400 or something like that. The gray ones, no record. The black ones with a circle, that's where a name is, but those are not on today. And then the yellow ones, those are lit for this week. And when you're on, the screenshot wouldn't do this, but when you're on the website and you roll over each of these locations, it will show you their name and their date of passing. Below this, there's a whole search function. Also for both Jewish holidays and also queer holidays, we can get all these to light up all at once. This one specifically is really important, especially to the queer community, because between the late 80s and the early 90s, there's a lot of names on this that a lot of people were lost to the AIDS epidemic. And we also did another one downstairs. Again, weird things that we make on site just to make life easier for us. I don't know, it's kind of like contemporary art to me. This is the back of the wall, but the front entrance. So the entrance actually to the sanctuary is right here. So you walk in and you see this with no names. It's kind of abstracted, and it kind of gives you like a more, a feeling that this is important, but you don't actually have specifics about these people. We turned a bunch of lights on for the photo, but usually there's about 4 to 6 of these lit. This wall, 2 pieces of glass, is also acoustic. That's really why they wanted this. That's one of the reasons they wanted this. This is what it looks like from the front. So one of the reasons that I thought about this, and it's a pretty simple concept, obviously this tradition goes back to biblical times. I mean, you could find one of these in Jerusalem, right? And obviously no LEDs in back in the day. But this little idea of this little flame sitting here like this is something that's basically, it's almost intrinsic to an LED. This is the way that LEDs emit light. And so if you, and you can look at them on our LEDs back there, if you do it correctly, it kind of looks, it's kind of like a tea light, right? I mean, it's not flickering obviously, but it's kind of like a tea light. So I said, well, I think it would be nice to illuminate each of these names. We just set the LED underneath it, and then the name is applied to the wall. I mean, they get a vinyl cutter to come and install it. And I mean, my goal is to try and make these solutions as simple as possible. The other thing that we did was the near to mid, which is the eternal flame. This one is actually USB powered. So when we blessed it with the benefactors of it, he climbed up on a ladder and plugged in the USB, and then we popped the champagne and celebrated. You might be asking why this column is there. It was about $12 million to remove this column, so they kept it. This is the last one that I'll show you, and this one is really kind of a homecoming for me at the Seattle Asian Art Museum. This is a 1932, it's an Art Deco building. It's in the National Register, and my grandparents were really involved in this museum. My grandfather taught art at the University of Washington for a long time, and my grandmother was part of the museum board for a long time. And the museum was recently renovated by LMN, and they had added a whole bunch of space to the back of it. And these apertures that you barely see were new. But I had spent a lot of time in this space, like a lot. I mean, running around like this tall, and kind of not like in a conscious way, but unconscious way, knew a lot about this space. This is based on this fabric motif called ECAT. I studied textile design, and one of the things that's crazy about this is that this pattern is based on selective dyeing of the thread. So before you put this on the loom, you have to dye the thread in specific patterns and then put it on the loom. And then those areas which are not dyed coincide and you get these patterns. And one of the reasons I really like this is because you basically put this design and this construction method together. I wouldn't say that you've saved time, but you have saved a step. And it's a lot of planning, obviously. Like you have to figure out how you're going to even dye the fabric, I mean, the thread before you get it on there. And so that kind of baked togetherness is something that I really respect. Let's talk a little bit about how this comes together from a design perspective. They gave us drawings. I modeled it in Rhino. The truss system came from MKA, and they said that this cannot be more than like 5,000 pounds. So that was not a problem actually for us, and something that a lot of architects really like. This is the space that the museum designated. It is 2510 by 48.8 and a 10-foot drop. They said, well, we could just kind of do this parabolic thing. Kind of interesting. Could be more interesting if we had a second layer. But I had spent time talking to my team, and we knew that the strands were going to go left to right. And also, one of the things, just to back up a little bit, one of the things that made this possible is that my team is always like on these YouTube, not on YouTube, but just on Chinese kind of factory websites, finding new LED technology that's coming out. So we're using a COB, chip on board technology. I mean, you can see one back there, it's right there for you. And it gives us these opportunities because we're essentially building these LED elements from scratch. But because I wanted to make these as simple as possible and them all the same, I essentially said, well, if we make them all the same, but the ceiling part converges, we will get this part, the front, to dip. This one's parabolic and this one's catenary, if you can tell the difference. And this is the video that I sent them straight out of Rhino. We're not very advanced in this part of the process, as you can see. This is basically just a screen capture of the Rhino. And then I send them a sample exactly like the one you see in the back. And I say, it's gonna be this thing, lots of them, and it's gonna look like this. And then hopefully their imagination takes over. How do we mount these? Guitar tuners with a 3D printed base. These are mounted inside the channels, and these are great. You can, if we tighten the whole thing, the strand goes up. If we loosen them, the strand goes down. If they're off center, we can move it left to right. This is the view you'll never see from the scissor lift. So again, we validate all the electrical things, parts of it, to make sure that it works on ground level. And then 2 people per lift, synchronized lifting, always, well, you know, they're soft goods, so it's not too crazy, but yep, one at a time. And then we stand there and we tell them whether or not they're on axis. And it actually didn't take that long. Once all the parts are there, this took about a day, less than a day. And it looks like this. It's a very non-standard shape. And I named it Gather for a couple of reasons. One is this is one of the main event spaces at the museum. 2, from a fabric perspective, this is a gather. This shape and method, bringing these 2 things together is gather. And then also I have been thinking and reading a lot about space particles during this time. And I just imagined all of these space particles and gamma radiation and stuff coming through this clear story and landing on this thing. And there's this very nice donut-shaped Isamu Noguchi sculpture in front. And I had just imagined all of these particles flowing through this donut and then shooting directly at the Space Needle. Here's the axial view. This is sunset. And this is the opposite view. This is the entry and the view from the entry. Thank you.